So looking at question 1, you can see in the top left box, this is what they've told us initially. In other words, the ball is traveling at 24 meters per second at an angle of 30 degrees to the horizontal. So if we then work out through SOHCAHTOA what the vertical velocity is, because that's the most important thing that we're going to need here. The vertical velocity, you use SOH, so the sine of 30 is the opposite over the hypotenuse, and that gives us a vertical velocity of 12 meters per second. Okay, and what we're interested in is when the vertical velocity reaches 0. So that's the point where it stopped going up and is just about to start coming back down again. That's obviously the highest point that it's going to reach. And so we're looking for how to get that vertical velocity to 0. And we know that the change in velocity is the acceleration times time. And if you look at that from a units point of view, change in velocity is meters per second, acceleration is meters per second, and time is seconds. So if you multiply those out, you get the right units. It's always worth checking the units because it sometimes helps if you don't quite understand things. So the change in velocity is 12 meters per second. That's going from an initial velocity of 12 to a velocity of 0. And we know that the acceleration is gravity, and they give us that in the formula sheet as 10 meters per second, or 10 meters per second squared. And we know that if we rearrange the change in velocity equals acceleration times time, we can get time equals velocity divided by acceleration, or 12 meters per second divided by 10 meters per second squared. And that comes to 1.2 seconds. So now we know how long it takes for the ball to reach the peak. And then we can work out the distance because we know the time and we know the average velocity because it starts at 12 and then finishes at 0. So the average velocity is 6 meters per second. The time is 1.2 seconds. So the distance is 7.2 meters. Oops, sorry. The distance is 7.2 meters.